NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will determine two numbers when we know their sum and their product. We will build the quadratic, whose roots are those two numbers, and then solve it step by step. Here is the universal idea. If x1 and x2 are the unknown numbers with some capital S and product capital P, then x squared minus sx plus p equals 0 has roots x1 and x2. So we first write the template. The two numbers we seek will be the solutions of this quadratic. Now, let us solve a concrete example. Given the sum is 7/6 and the product is -1/2. Substitute these into the template. To make life easier, clear the denominators by multiplying both sides by 6. This gives 6x squared minus 7x minus 3 equals 0. We now have a clean quadratic with integer coefficients. Next, compute the discriminant delta, which is b squared minus 4ac. Here a equals 6, b equals -7, and c equals -3. Delta equals -7 squared minus 4 times 6 times -3, which is 49 plus 72 equals 121. Now apply the quadratic formula. X equals -b plus or minus the square root of delta all over 2a. Substituting b equals -7, a equals 6, and delta equals 121, we get x equals the quantity 7 plus or minus 11 over 12. Therefore, x prime equals 3/2 and x double prime equals -1/3. These are the two numbers whose sum is 7/6 and product is -1/2. Let us make a quick visual check on the graph of 6x squared minus 7x minus 3. We draw axes, plot the parabola, and mark the intercepts at -1/3 and 1.5. Notice how the curve crosses the x-axis exactly at those values. Finally, let us verify the sum and the product. Sum equals 3/2 plus -1/3, which is 7/6. Product equals 3/2 times -1/3, which is -1/2. Everything checks out. Conclusion: the required numbers are 3/2 and -1/3. You can always use this method. Build x squared minus sx plus p equals 0, clear fractions if needed, find the discriminant, apply the quadratic formula, and check. Example: we will determine two numbers from their sum and product. The product of two numbers is -1, and the sum is 4. We will follow the classic algorithm. Express the quadratic with those roots, compute delta, and apply the quadratic formula. Step 1. Define the symbols. Let s equal x sub 1 plus x sub 2, which equals 4. Let p equal x sub 1 times x sub 2, which equals -1. Step 2. Build the monoquadratic whose roots are x sub 1 and x sub 2. That polynomial is t squared minus st plus p equals 0. Substituting s equals 4 and p equals -1 gives t squared minus 4t minus 1 equals 0. Step 3. Compute delta, the discriminant, with a equals 1, b equals -4, and c equals -1. Delta equals b squared minus 4ac, which is 16 plus 4, equal to 20. Step 4. Apply the quadratic formula. T equals -b plus or minus the square root of delta, all over 2a. That is 4 plus or minus square root of 20 over 2. Square root of 20 simplifies to 2 times square root of 5. So t equals 2 plus or minus square root of 5. Therefore, the two numbers are 2 plus square root of 5 and 2 minus square root of 5. As a quick check, their sum is 4 and their product is -1, exactly as required. Final answer. The numbers are 2 plus square root of 5 and 2 minus square root of 5. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.